Good evening everyone. Good evening. I welcome you all again to the JEE Enthuse. Hoping that you guys are doing great, having the good time. Well people, you can let me know in the chat box if I'm audible and visible to everyone. You can let me know in the chat box if I'm audible and visible to everyone. Welcome back everyone, welcome back. Welcome to the second session of the basic concepts of chemistry, right? And if you remember in the last session, we did the stoichiometry, yeah? We are going to continue with the stoichiometry, and in the tonight's session, we are going to start the limiting reagent as well, right? Hello, Mehul Akbar. Hi, Sambarta. Good evening. Hi, Akriti. Hi, Tushar. Hi, Laksha. Hi, Sanya. Hello, Jayawant. Welcome, guys. Welcome, everyone. Welcome back. Well, you can let me know in the chat box if I'm audible and visible to everyone. Tushar, I always take session at this time only, yeah. I always take session on this channel at 10:30, right? So you can let me know in the chat box with some green signal. Give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to you guys or not. Yeah, I'm doing great. Hello, Sanya, how are you? Perfect, guys, perfect. So, in the today's session, we are going to do the stoichiometry. We are going to continue the stoichiometry, and at the same time, we'll be doing one of the important topics from the chapter mole concept. That's what we call as limiting reagent. Okay? Perfect, guys. So for the ones who are new to the channel, let me introduce myself. My name is Wassim Sir, and I'm your chemistry master teacher right here on this channel. Okay? And for the ones who have not liked the video yet, please do like the video, share the video with your friends, and subscribe to the channel as well. And do not forget to hit the bell icon so that every single session notification you'll be getting. Yeah? Perfect. Yes, Tajita, this is for NEET as well. Anyways, you can check the NEET Elite channel. There I take these sessions for the NEET people. Okay? Laksha, I know I can understand a bit of Tamil, yeah, because Shimon sir, your maths teacher, he's one of my close friends, right? I've been knowing him from past 4 years now. Yeah, so I can understand a bit of Tamil. Kunjum terima, yeah? Perfect. Moving on. So you can let me know in the chat box if you guys are super duper excited about the session. Yeah? Let me know in the chat box if you guys are super duper excited about the session. Then we can start directly. Yes, Fahim, I remember you absolutely. Hi, Shubham, how are you doing? Perfect. Is that Mrinal? I like it. Oh, wonderful. Yes, I'll be teaching the empirical formula as well. Everything, every single topic I'll be covering right here. Okay? It is, just remember, I'll be taking 3 sessions a week, right? And this chapter is going to take 3 more sessions apart from this session. Okay, and after that, we'll be starting the atomic structure. Your whole class 11th course will be completed right here on this channel with me. Okay? But you need to follow it strictly, right? Perfect. Perfect, guys, perfect. I'm doing good. Perfect, guys. So let's get started with the today's session straight away. Okay? And I want you guys to take a note of every single thing which I'll be writing over here on the screen. First of all, let me know how many of you attended the Menti session with Shimon sir like few minutes back, right? How many of you attended that? Let me know fast how many of you attended the Menti session with Shimon sir? Of course, Akriti, मैं कश्मीर से हूँ, हिंदी में ही बात करता हूँ actually. Okay, let me know in the chat box how many of you attended the Shimon sir session. Did you guys attend that? That was the Menti session, yeah? It was so good. I personally liked it. Do watch that. It was nice. It was really nice. Sanigdha, I'm doing great. How are you? Okay, perfect. So people, let's get going. Let's get started right here with the today's session, yeah? In the last session, we talked about something called as stoichiometry. Correct? And tonight, we are going to continue with that stoichiometry only. And at the end, we'll be starting one more important topic of the mole concept, which is what we call as limiting reagent. Correct? Okay. Let's move on. Let's get started. First of all, let me show you the balancing of combustion reactions. First of all, you all must be knowing how to balance the combustion reactions. How to balance the combustion reactions. Let me make you understand this balancing of combustion reactions first, and then we can move on to the actual stuff which we have to do, okay? For example, remember, if you'll be having a general hydrocarbon as CXHY, right? I'm taking a general hydrocarbon as CXHY. X can be anything, Y can be anything, right? For example, X is 1, Y is 4. That means I'm talking about CH4, correct? X can be anything, Y can be anything, okay? If I'll make this CXHY, this hydrocarbon, to react with oxygen, remember, the products of this reaction are always going to be carbon dioxide and water, yeah? These will be always the products of this reaction, no matter which hydrocarbon you are going to take over here. I've taken a general hydrocarbon, CXHY. I'm going to make it to react with oxygen. It always leads to the formation of carbon dioxide and water, right? Number one. Number two, how do we balance this general equation over here? See guys, there is a simple trick by means of which you can balance this reaction. If I ask you how many carbon atoms do we have right here, we have got X carbon atoms. So you are going to take this X as the stoichiometric coefficient of carbon dioxide, yeah? How many hydrogen atoms do we have? We have got Y hydrogen atoms right here. Just do one thing, take Y by 2 as the stoichiometric coefficient of water, yeah? And what should be the stoichiometric coefficient of oxygen? Remember, it is always going to be X plus Y divided by 4. This is the general way by means of which you can balance this sort of a reaction over here, right? Okay? Exactly, Javant. Yes. Every time, whenever you'll be having a hydrocarbon, whenever you'll be doing its combustion in presence of oxygen, your products are always going to be carbon dioxide and water. Okay? Now people understand. Let me give you one example right here. Let's assume the value of X I'm taking as 1, the value of Y right here I'm taking as 4. Okay, if I'm taking X as 1, Y as 4, that means which hydrocarbon I'm talking about? C1H4, your methane, CH4. I'm going to make it to react with oxygen, yeah? And it will lead to the formation of carbon dioxide gas, and at the same time, what you'll be getting water as well, right? You'll be getting water as well. Now people, it's time to balance this reaction. And I've told you how to balance this sort of a reaction, okay? Santosh, this is the first chapter. People understand. If I ask you, what is the value of X right here? The value of X right here is 1. What is the value of Y over here? The value of Y over here is 4, right? Whatever is the value of X, take this X as the stoichiometric coefficient of carbon dioxide as I told you earlier. So it becomes 1. What is Y value over here? It's 4. Take the Y by 2 as the stoichiometric coefficient of water. That means 4 divided by 2 comes out to be 2. So 2 is the stoichiometric coefficient of water, yeah? What about the stoichiometric coefficient of this oxygen over here? It's going to be X plus Y by 4, right? What is X? X value is 1. X plus Y by 4. Y value is 4 divided by 4. 1 plus 4 by 4 comes out to be 2. So 2 will be the stoichiometric coefficient of oxygen over here. The reaction would have got automatically balanced, right? Okay, right here, the reaction would have got automatically balanced. CH4 plus 2 times O2 gives 1 times carbon dioxide plus 2 times water. Okay, this is how we balance the general combustion reactions. I want you guys to take a note down of this thing in general, okay? Why am I telling you this? There is a reason for it. There is a reason for it, okay? Right? Let's get to know. Let's get to know. For example, I'm writing a question over here, and the question is, let's assume like this. Just give me a second. The question is, calculate the volume of carbon dioxide. Calculate the volume of carbon dioxide liberated at STP during the combustion of 570 grams of octane. A very simple question I'm writing, and I'm sure you all can solve this one easily, provided you remember the last session, yeah? The question says, calculate the volume of carbon dioxide liberated at STP during the combustion of 570 grams of octane, right? Now people understand how to approach to this sort of equation over here. First of all, you are going to write the reaction. You're going to write the reaction. What am I doing over here? I'm doing the combustion of octane. I'm doing the combustion of octane. That means I'm making this octane to react with oxygen, yeah? I'm making this octane to react with oxygen, right? So what is going to happen over here? Understand. I'm going to take the octane, whose formula will be C8H18. I'm sure you all must be knowing the formula for octane, C8H18, right? I'm going to make this octane to react with oxygen. Yeah. What are going to be my products? My co-products are going to be carbon dioxide gas and H2O gas. This is something which I told you a few minutes back. Whenever you do the combustion of any hydrocarbon, it always leads to the formation of carbon dioxide and water. Okay. Now people understand. If you remember, in the last session I told you, in the last session of stoichiometry, I told you always to balance the reaction first. If I ask you, is the reaction balanced or not? The reaction right now is not balanced, okay? The reaction is not balanced, right? So what I'll be doing, I'll try to balance the reaction. And a few minutes back, I told you how to balance these combustion reactions. Understand. What is the value of X over here? The value of X is 8. So take this 8 over here. It's going to be the stoichiometric coefficient of carbon dioxide. What is the value of Y over here? The value of Y is 18, correct? The value of Y is 18, and Y by 2 is going to be the stoichiometric coefficient of water. So 18 divided by 2 comes out to be 9. This 9 is the stoichiometric coefficient of water. Now what about the stoichiometric coefficient of oxygen over here? Isn't it simply going to be X plus Y by 4? X plus Y by 4, right? What is the value of X? That's 8. What is the value of Y? Y is 18 divided by 4, yeah? So it's going to be 2, 9, 2, 2. So it's going to be 25 divided by 2. So 25 divided by 2 is going to be the stoichiometric coefficient of oxygen over here, right? You can either write it in this form, 25 by 2, or you can multiply this reaction throughout by 2 so that it becomes 2 times, it becomes 25 times, it becomes 16 times, it becomes 18 times, right? Okay. Now see what I'll be doing. I have balanced the reaction, yeah? Now what I'm going to do is, I'm going to convert the given quantity into number of moles, right? Just look at the equation, see what is the given quantity. I'm given with the mass of octane. First of all, I'll be converting the mass of the octane into number of moles of octane, yeah? So number of moles of octane is going to be equal to given mass of octane, which is 570 grams, divided by molar mass of octane. When you'll calculate, it comes out to be 114. The value will be 5, right? So I got the number of moles of octane as well, okay? Now what I'll be doing, understand. I was given with the mass of octane and I'm supposed to calculate the volume of carbon dioxide liberated. What I'm supposed to calculate, understand. As with the equation, if you'll be having 570 grams of octane, if you'll do the combustion of 570 grams of octane, what will be the volume of carbon dioxide liberated at STP? That's something which we are supposed to calculate, yeah? How will I be doing it? Understand. First of all, I'm given with the mass of octane and I'm supposed to calculate the volume of carbon dioxide. That means I've got nothing to do with this oxygen right here. I've got nothing to do with this water right here. Okay. So what I'll be doing, I'll be simply using the stoichiometry. Right here, the stoichiometric coefficient is 1. Right here, the stoichiometric coefficient is 8. Now, people, from the stoichiometry of the reaction, can I say simply 1 mole of octane? 1 mole of octane gives what? 1 mole of octane gives 8 moles of carbon dioxide, right? 1 mole of octane gives 8 moles of carbon dioxide. From the stoichiometry of the reaction, I can clearly say 1 mole of octane gives 8 moles of carbon dioxide, okay? So if 1 mole of octane, from the stoichiometry, if 1 mole of octane gives 8 moles of carbon dioxide, can I say 5 moles of octane, right? 5 moles of octane are going to give me 8 multiplied by 5, which is going to be 40 moles of carbon dioxide. So till now, you got to know 40 moles of carbon dioxide are being liberated when I'm doing the combustion of 5 moles of octane, when I'm doing the combustion of 570 grams of octane, right? So you got to know the number of moles of carbon dioxide which are getting liberated, comes out to be 40 over here, yeah? But people, am I supposed to calculate moles of carbon dioxide liberated or volume of carbon dioxide liberated? I'm supposed to calculate volume of carbon dioxide liberated, right? And the condition is given as STP, yeah? So I'll be writing volume of carbon dioxide liberated is simply going to be equal to number of moles of carbon dioxide liberated multiplied by 22.4 liters, right? Number of moles of carbon dioxide liberated is 40 multiplied by 22.4 liters. It comes out to be 896 liters. So you got to know 896 liters of carbon dioxide are being liberated when we are doing the combustion of 570 grams of octane. As simple as that. This is something which we were supposed to calculate. You can let me know in the chat box. You can give me some green signal from the chat box if you got the concept. Let me know in the chat box. Let me know in the chat box if it is clear to you. Yeah? Gaurav, I sleep late, bro. Bhumi, you can check it out. It will come out to be the same. You just balance the atoms on both the sides. Okay? Let me know in the chat box if it's clear to everyone. Thank you, Tushar. Thank you. Perfect. Wonderful. Let's move on. Let's move on. Now, people, there is one more method which I'm going to show you right now. That's what we call as POAC method, Principle of Atom Conservation method. There is one more method right here. That's what we call as POAC, Principle of Atom Conservation method. Yeah, Principle of Atom Conservation method. First of all, where do we use this method of POAC? Where do we use it? Understand and remember. Whenever you'll be getting a question in which you won't be able to balance the reaction, okay? Whenever you'll be getting a question in which you'll be unable to balance the reaction, at that time, we use the method called as Principle of Atom Conservation method, right? So first of all, if you remember, in stoichiometry, I told you your first step always should be to balance the reaction. But there will be some reactions which will be incompletely given to you, which you won't be able to balance. For those reactions, do use this Principle of Atom Conservation method, okay? So the first benefit of using the Principle of Atom Conservation method is you're not supposed to balance the reaction, okay? Now, what this POAC method is all about, okay? How to apply this POAC method in the questions, understand properly what I'm going to do over here. Understand properly, right? Look here, guys. For example, I have got a general reaction like this. Let's say I've got a general reaction as A3B2 plus, for example, plus B2C4. It gives, let's keep it as A4C5 plus B2D3. Okay? Let's say this is one general reaction which is given to me. Let's assume this is one general reaction which is given to me, correct? Before using the Principle of Atom Conservation method, you should know few things about it, right? Let me tell you, you should know how to write the POAC equations. You should know how to write the POAC equations. And let me tell you, the POAC equation is written for the atoms. It is written for the atoms, okay? First thing, POAC is written for the atoms. Understand what I'm going to say. Let me show you how to write the POAC equation for atom A. Understand how to write the POAC equation for atom A. See, guys, first thing, I'll be starting with this reactant over here. How many atoms of A do we have over here? 3 atoms. So I'll start with 3 multiplied by number of moles of this whole compound over here. Number of moles of this whole compound over here, right? Do we have A over here? A is not in this reactant right here. So I've got nothing to do with this B2C4 right here. Instead of this arrow, I'll be using the equality sign. Now, do we have A right here? Yes, we have got 4 atoms of A. So I'll be writing 4 multiplied by number of moles of A4C5. Yeah. Do we have A over here? We do not have A over here. Yeah. So I'll say this is one complete equation, complete POAC equation in terms of A atoms. Number 1. Number 2. Understand. If I'll write the POAC equation for atom B, okay. So what I'll be doing, understand. I'm going to make the POAC equation for atom B. Do we have B atoms over here? Yes, we have got 2 atoms of B. So I'll be starting with 2 multiplied by number of moles of this whole compound, which is A3B2. Okay. Do we have B right here? Yes, B we have 2 atoms of B. So I'm going to make it like this. This is plus sign which was in between. 2 atoms of B we have. So this is 2 multiplied by number of moles of this whole compound, which is B2C4. Instead of this arrow, as I told you, I'll be writing the equality sign, right? Do we have B over here? No, that means I've got nothing to do with this. Do we have B right here? Yes, we have got 2 atoms of B. So I'll be writing 2 multiplied by number of moles of B2D3. Yeah, this is one more complete POAC equation in terms of atoms B. Okay, so you can let me know in the chat box if you can write the POAC equation for different atoms in a chemical reaction. The first benefit of using POAC is we are not supposed to balance the reaction. Yeah, that is the important thing about this POAC. Okay, so you just let me know in the chat box if you can write the POAC equation for different atoms in a reaction. Let me know in the chat box so that I can show you its application part. Let me know in the chat box. Perfect. Wonderful. Manjima, you can do one thing. You can just drag the video a little back. It'll be automatically a replay for you, okay? You just drag the video a little back. It'll be automatically a replay, okay? Perfect. Wonderful. Let's move on then. Let me show you how this concept of POAC is used. How this concept is used. Understand what I'm going to do. I'm going to start with a question, okay? Just a second. Okay, this is the question on your screen. Okay, let's try to solve this question over here. See how will I be solving this question. Understand properly what I'm going to do. Understand the question, what is given in the question and what we are supposed to calculate. Okay, happy to just drag the video a little back. It'll be automatically a replay for you, okay? Black Pint is asking, sir, please Hindi में समझा दो. Bro, it's an English channel, so Hindi में बात करने की permission नहीं है, ठीक है? Okay, this is the English channel. That's why I'm talking English. Otherwise, you know it, okay? Yes, nurture series will be regular from now onwards. Yeah. Right? Okay, let's move on. Let's move on, guys. Let's see how this question is to be solved. It's one common question, okay? How do we solve this sort of equation over here? Understand? See, guys, as per the question is concerned, it's mentioned to me as I have got 27.6 grams of K2CO3. 27.6 grams of K2CO3 was treated by a series of reagents, okay? So basically, as per the question, I have got K2CO3 and I have got 27.6 grams of K2CO3. And I'm treating with a series of reagents. I have no idea what these reagents are. Yeah, I have no idea what these reagents are. Let me call these reagents as A, B, C, D, okay? So basically, I've got K2CO3 and I'm making this K2CO3 to react with the series of reagents so as to convert all the carbon, whatever carbon was there in K2CO3, it is finally reaching to the product. The product of this reaction is K2ZN3 FeCN6 whole twice. Yeah, this is the question which is given to me. Understand properly what is given in the question. See, guys. Javant, you can remember it like this. Your reagents are reactants basically, okay? Okay? When I'll be starting the organic, there I'll be giving you the exact definition of reagent, substrate and everything, okay? But till now, you can understand it like this. The reagents are reactants, okay? Now we will see. As per the question, 27.6 grams. I have got 27.6 grams of K2CO3. And I'm making these 27.6 grams of K2CO3 to react with the series of reagents. And whatever carbon was there in K2CO3, that carbon is finally reaching to this product. I need to calculate how many moles of this product are formed, right? What is the mass of the product formed? I need to calculate it as per the question. What is the mass of product formed? How do we solve these sort of questions? Understand? How do we solve these sort of questions? First of all, can you let me know, can we balance the reaction? Can we balance the reaction? Just let me know in the chat box, can we balance the reaction? Biology atomic structure will be done after this chapter. Can we balance the reaction? We cannot balance the reaction, right? Why is that? Because we are not given with the other reactants. Okay, if we are not given with the other reactants, that actually means we cannot balance the reaction. Okay? Sakshi, just drag the video a little back, it'll be a replay for you. Okay? Since we are not given with the other reactants, so we cannot balance the reaction. And when we cannot balance the reaction, which method do we use at that time? We use the principle of atom conservation method. Yeah? Right? So people, how do I use principle of atom conservation method in this question? First of all, understand. I'm given with 27.6 grams of K2CO3. Right here, again, this first step is same. Whatever is the given quantity, convert the given quantity into number of moles. So first of all, I'll be calculating the number of moles of K2CO3. It is simply going to be equal to mass of K2CO3, which is 27.6, divided by molar mass of K2CO3. When you will calculate, you'll find out to be as 138, something like this, yeah? Okay, so these many moles of K2CO3 we have actually, Okay, till then you can do the calculation. You can let me know what is the exact value coming out to be from here. 27.6 divided by 138. These many moles of K2CO3 I have got right here with me. Okay. Now I'm going to make these moles of K2CO3, I'm going to make this 27.6 grams of K2CO3 to react with many of the reactants. Then only I get this product. Okay. Now people understand. Number of moles of K2CO3, you'd have calculated it and you'd have got it something as 0.2. So basically, I've got 0.2 moles of K2CO3 right here. Okay. Now since I cannot balance the reaction, so I cannot use the normal method of stoichiometry, I'll be using the POAC, right? Now first of all, in order to use the POAC, you should know for which atom POAC equation is to be made, yeah? You should know first of all, for which atom POAC equation is to be made. Understand. Look at this reactant. This is K2CO3. Look at this product right here. This is K2ZN3FeCN6 whole twice. If I ask you which one is the common atom in between them, you will say there are two common atoms in between them. Okay? There are two common atoms in between them. Okay? What are these two common atoms? One is your potassium. Potassium is the common atom. And at the same time, carbon is the common atom as well. Right? So we have got two common atoms. One is potassium, one is carbon. Now, remember, POAC equation is written for the common atoms. POAC equation is written for the common atoms, right? But over here, we have got two common atoms. Now, for which common atom do we write the POAC equation? We will write the POAC equation for that atom which remains conserved in the reaction. Now, how to identify which atom remains conserved in the reaction? Understand, it's mentioned as per the equation. Whatever carbon was there in K2CO3, that entire carbon is reaching into this product. So carbon atom is remaining conserved in the reaction. Okay? Carbon atom is remaining conserved in the reaction because it's mentioned as per the equation. Whatever carbon was there in K2CO3, that entire carbon is reaching into the product. So basically, your carbon is being conserved in this reaction. So if carbon is being conserved, so I'll be simply writing the POAC equation for carbon atoms. Yeah? Now people understand. I got to know POAC equation is to be written for the carbon atom, right? So if I ask you how many carbon atoms do we have in this K2CO3, we have got one carbon atom, right? So I'll be writing 1 multiplied by number of moles of this whole compound, yeah? Number of moles of K2CO3, absolutely. Okay? And this is the arrow in between. Instead of arrow, I'll be using the equality sign. On the right hand side, we have got K2ZN3FeCN6 whole twice. If I ask you, how many carbon atoms do we have right here in this compound? This is 6 and this is 2 from outside. So 6 2s are 12. So we have got 12 carbon atoms in this product right here. So 12 multiplied by number of moles of this whole compound, which I call as P. Number of moles of product. Number of moles of this whole compound. Yeah? Okay? Right? Now people understand. I'll be writing it like this. 1 multiplied by number of moles of K2CO3. I have already calculated. As you can see, it's 0.2. It's 0.2 is equal to 12 multiplied by number of moles of products. So from this equation, can I calculate the number of moles of product? Isn't it going to be 0.2 divided by 12? So these many moles of products are being formed as per the equation, right? So we got to know these many moles of product are formed. Okay? But people, am I supposed to calculate moles of product formed or mass of product formed? I'm supposed to calculate mass of product formed. Yes, I got the moles of product formed and we know how to convert moles into mass. I'll be writing something as mass of product formed is going to be equal to number of moles of product formed multiplied by molar mass of product, right? So number of moles of product formed, it is 0.2 divided by 12 multiplied by molar mass of product. When you will calculate the molar mass of this product, potassium, it has got the molar mass of 39, zinc 63.65, iron 56, right? Carbon 12, nitrogen 14. When you will calculate the molar mass of it, you'll get to know it as 698, correct? You can just solve this value. These many grams of product would have got formed at the end of the reaction. Okay, so I'm sure this is clear to everyone. Let me know in the chat box if it's clear to you or not. Let me know in the chat box if it's clear to you or not. So remember, exactly, it was a basic mains level question, right? It was a basic mains level question, right? Anish, I told you Why am I not writing POAC for potassium atom? Because potassium is not remaining conserved, right? Otherwise, it would have been mentioned in the equation that potassium is getting converted. Whatever potassium is there in reactant, it's getting converted into the product, but it's not mentioned. Okay? Right? Let me know in the chat box if it is clear to everyone. Give me some thumbs ups in the chat box. Bhumi, there won't be. Otherwise, it would have mentioned in the equation. Abhishek, I always take classes at night only. At 10:30, I always start on this channel. Right? Okay. Should I be moving on? Perfect. Let's try to do one more question based on the same concept. Yeah. Let's try to. So at the end, you are getting this much as the answer. 11.6 grams of product. You will see these many products, these many grams of products would have got formed at the end of the reaction. Right? Well, people, I've got one more question right here on the screen. Okay. This is one more important question. Understand? Look here. See how do we solve this question. I'm given with 3 reactions right here. First of all, you must know what are sequential reactions. For example, I've got the reaction in which A is getting converted into B. The B which is getting formed in the first reaction, let's say that B is getting converted into C. The C which is getting formed in the second reaction, that C is getting converted into D. Yeah? So people, if I'll add these 3 reactions, can I say this B and this B will get cancelled out, this C and this C will get cancelled out, so my net reaction is going to be A getting converted into D. This is my net reaction, correct? This is my net reaction. So people, should I be calling this reaction over here as the sequential reaction? Okay. It is getting completed in a sequence. First A is getting converted into B, then B is getting converted into C, then C is getting converted into D. So this kind of a reaction is what we call a sequential reaction. Okay, multi-step reaction you can say. Okay, now people understand. Properly understand. Okay. Sakshi, you can sleep. You can watch this session afterwards. Okay, it's going to remain over here on the channel. Okay, no issues at all. You can sleep. Right? Now people understand. I'm given with 3 reactions. CaC2 is reacting with water. It's leading to the formation of calcium oxide, and with this calcium oxide, you get C2H2 as well. The C2H2 which you are getting formed in the first reaction, that is reacting with H2, and you are getting C2H4 over here. This is C2H4 right here. Just a second. Okay. This is C2H4 over here, yeah? And once C2H4 is being generated, then N molecules of C2H4 are reacting and they are forming a compound like this. This is what we call as polyethylene, okay? C2H4, and right here outside the bracket you have got N. This is something which we call as polyethylene. Calculate the mass of polyethylene that can be produced from 10 kg of calcium carbide, right? This is the equation on your screen. How do I solve this sort of equation? Calculate the mass of polyethylene. I need to calculate the mass of polyethylene that can be formed, that can be produced when we start with 10 kg of calcium carbide, right? If I'll start with 10 kg of calcium carbide and I'll make these 10 kg of calcium carbide to react with water so that calcium oxide gets formed and C2H2 gets formed. The C2H2 which gets formed, that again reacts with H2, leads to the formation of C2H4. C2H4 which gets formed in the second step, N molecules of C2H4 reacts, they lead to the formation of polyethylene. I need to check how many grams of polyethylene have got formed at the end of the reaction, right? Now understand what I'll be doing. Let me write the reactions again. The reaction is CaC2, or let me not write the reaction. Let me just do one thing. Let me take calcium carbide and this polyethylene from everything, okay? I'm taking only CaC2 right here on the reactant side, and on the product side, I'm only taking one thing, that is my polyethylene, which is C2H4N over here. Yeah, this is what we call as polyethylene. Okay, right? I've taken only calcium CaC2, and over here I've only taken C2H4, right? Now people understand. The mass of calcium carbide is given to us. It's given to us as 10 kilograms. And mass of this polyethylene we are supposed to calculate. That's why I only took these two. That's why I only took these two, right? The mass of calcium carbide is given to us. And the mass of polyethylene is something which we are supposed to calculate, right? Now people understand. Properly understand. Maharul Akar. These are not minus signs, okay? This is something, this carbon is attached with one more something, one more carbon, right? Right? See guys, if I ask you, what is the first step? What is the first step which we'll be doing if I use POAC in this question? What is the first step which I should do? First thing, I'll be converting the given mass of the substance into number of moles, right? So I'll be calculating the number of moles of calcium carbide first. It's going to be equal to mass of calcium carbide, which is 10,000 grams, divided by molar mass of CaC2, which comes out to be 40 plus 24, that is 64. So these many moles of CaC2 we have actually, okay? These many moles of CaC2 we have actually. Now people understand. For which atom I'll be writing the POAC? Now, just check which one is the common atom in between them. You have got carbon as the common atom. So I'm going to make POAC for carbon atoms. Okay, understand. How many carbon atoms do we have right here? We have got 2 carbon atoms multiplied by number of moles of this CaC2. Number of moles of CaC2. Instead of this arrow, I'll be using equality sign. Now, if I ask you, how many carbon atoms do we have right here in this polyethylene? Is it 2 or 2n? We have got 2n carbon atoms in this polyethylene. So I'm writing 2n multiplied by number of moles of this whole compound, which is polyethylene. Yeah, right? I can say this. Okay, now people see. I'll be writing something like this, 2 multiplied by number of moles of CaC2. Have I calculated the number of moles of CaC2 already? It is 10,000 divided by 64, yeah? It is 10,000 divided by 64, okay, is equal to 2n, or let's cancel this 2 and 2 over here only. No need to write this 2, right? Let's take this n in the denominator over here. So you get the number of moles of polyethylene. But people, am I supposed to calculate number of moles of polyethylene? Mass of polyethylene. I'm supposed to calculate the mass of polyethylene, right? Since we got the number of moles of polyethylene, how will I be calculating the mass of polyethylene? I'll be writing mass of polyethylene formed should be equal to number of moles of polyethylene multiplied by molar mass of polyethylene, right? Okay. And if I ask you how many moles of polyethylene do we have? We have got 10,000 divided by 64 n moles of polyethylene, right? So I'm going to write it as 10,000 divided by 64 n moles of polyethylene multiplied by. What is the molar mass of polyethylene? Understand. What is the molar mass of this polyethylene? It's going to be, carbon has got the atomic mass of 12. So 12 multiplied by 2 comes out to be 24. Plus hydrogen has got the atomic mass of 1. 1 multiplied by 4 is equal to 4, right? So is the 28U, is the 28 AMU the molecular mass of this polyethylene? No. 28U is not the molar mass of polyethylene. 28U is not the molecular mass of polyethylene. Just a second, let me write it like this. See, I got the moles of polyethylene, right? I need to multiply these moles by the molar mass of polyethylene. If I ask you what is the molar mass of polyethylene, is it going to be 28 grams or 28N? Is it going to be 28 or 28N? It's going to be 28N, yeah? Right? It's going to be 28N because we have got N over here, yeah? It's not going to be only 28, it's going to be 28N. So 28N is the molar mass of this polyethylene. So I'm going to multiply it with 28N. This N and this N gets cancelled out. So you can solve it. Whatever the value you are getting, that is going to be the mass of polyethylene which is getting formed at the end of the reaction, which I was supposed to calculate, yeah? Let me know in the chat box if it's clear to everyone so that I can move on to the next question. Next concept, which is something which we have to talk about in the today's session, the limiting reagent concept, the actual concept, right? So I got the number of moles of polyethylene, I'm multiplying it by molar mass of polyethylene, which is 28 multiplied by N, because we have got N particles, you can say, N particles of this C2H4. Right? Surely, Rudresh, I'll be doing that as well. Balaji, for physical chemistry, you can go for N Avasthi. Okay? So people, you can watch the replay of this question afterwards as well, right? Recording will be there on the channel itself, right? So if you'll be having any sort of doubt in this, you can watch the replay. If still the doubt will be there, then you can do one thing. You can write the doubt in the comment box afterwards. Okay, and once you write the doubt in the comment box afterwards, I'll be making you understand the same in the comment box as well. Okay. नहीं भूमि पंजाबी नहीं हूं मैं कश्मीर से हूं. Yes, Parth, I'll be doing that as well. Yeah, no issues. So should we get started with the actual topic which we have to cover in the today's session? Should we get started with something called as limiting reagent? Let me know in the chat box. Nitya Priya, from next week, I'll be doing the classes for class 12th as well. Let me know in the chat box. Let me know in the chat box. Should we start the limiting reagent topic? Yeah? Okay, so let's move on. One of the most important topics from the mole concept, yeah? So do understand it properly. No, gamer buddy, I cannot speak Malayalam, even though in college I had a lot of Malayali friends. Yes, Ramji, I'll be telling you that as well. Okay, there is one simple trick to identify the limiting reagent. That's it. Okay, let's move on. Let's get started with something called as limiting reagent. So first of all, what is limiting reagent all about? What is limiting reagent all about? Let me write the definition of the limiting reagent. I'll say that reactant which gets completely consumed, that reactant which gets completely consumed in the reaction, that reactant which gets completely consumed in the reaction, that's what we call as limiting reagent. That reactant which gets completely consumed is what we call as limiting reagent. Yeah? Prarthana, you can do one thing, you can just refresh your page once, because on my side the connectivity is all okay, the screen is not a blur at all, I can see it from my phone as well. Okay? Right? Perfect. So let's let's understand the concept of limiting reagent over here. Understand properly what I'll be doing. Okay? Understand properly. For example, I've got the reaction as A plus B. It gives C plus D. Let's say that this is the general reaction which I'm taking over here. Yeah? So first of all, what is going to happen over here? Understand. This A and B, these are the reactants of the reaction, and C and D, these are the products of the reaction. Yeah? This A and B, these are the reactants. Right? I'm writing something as time t is equal to 0. Time t is equal to 0 means the reaction has not started yet. The reaction has not started yet. What does that mean? That means A has not reacted with B yet to form C and D. Okay? I'm writing time t is equal to 0. Time t is equal to 0 simply means that the reaction has not started yet. Okay? A has not started reacting with B yet. A has not reacted with B yet to form C and D. Right? Now understand. Let's say at time t is equal to 0, I have got, for example, 10 moles of A and 10 moles of B. Okay? When the reaction has not started, at that time I have got 10 moles of A and 10 moles of B. Since the reaction has not started, that means A has not reacted with B yet, so there will be 0 moles of C and 0 moles of D at time t is equal to 0, right? So at time t is equal to 0, I'll be only having reactants with me. And I have got, for example, 10 moles of this. Let's not keep it as 10 moles, let's keep it as 5 moles, yeah? And 5 moles of B, okay? So at time t is equal to 0, I have got 10 moles of A and 5 moles of B with me. So at that time, there'll be no product which would have got formed as per the reaction, okay? Now people, when this reaction will start, what is going to happen? When this reaction will start, what is going to happen? A will start reacting with B, okay? A will start reacting with B. And C and D will eventually get formed, right? Now people, I started with 10 moles of A and 5 moles of B, right? I started with 10 moles of A and 5 moles of B. Can I say number of moles of A and B will start to decrease with time because A will start reacting with B? Few moles of A will start reacting with few moles of B and they will lead to the formation of C and D over here. So I can clearly say number of moles of A and B over here are going to decrease, right? 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 Let me know in the chat box if it is clear. I'll simply say the number of moles of A and B, when the reaction will start, the number of moles of A and B will start to decrease because few moles of A will start to react with few moles of B, correct? Right? Now people understand. Now people understand. Understand properly what I'm going to say. At time t is equal to 0, when the reaction has not started, at that time I have 10 moles of A and 5 moles of B. 0 moles of C, 0 moles of D. When the reaction will start, number of moles of A and B will start to decrease, right? Right? The number of moles of A and B will start to decrease, right? So can I say one of these reactant will get completely consumed in the reaction? Okay, I'm assuming B is getting completely consumed in the reaction. For example, I started with 5 moles of B. After some time, you'll observe there will be 0 moles of B left in the container. There'll be 0 moles of B left in the container, right? Remember, that reactant which gets completely consumed in the reaction, that's what we call as limiting reagent. That reactant which gets completely consumed in the reaction, that's what we call as limiting reagent. So I'm assuming out of 5 moles of B, I'm left with 0 moles of B. So B got completely consumed in the reaction. So B is my limiting reagent over here. Yeah. Right? If B is the limiting reagent, the other one automatically it's called as excess reagent, because this A, I started with 10 moles of it. The 10 moles of A, they are not going to completely get exhausted, okay? These 10 moles of A are not going to get completely exhausted. At the end of the reaction, there will be few moles of A in the container as well. Understand once again what I'm telling you. I started with 10 moles of A, 5 moles of B, correct? Okay, now during the course of the reaction, when the reaction will start, the number of moles of A and B will start to decrease, and there will be a time when one of the reactant will get completely consumed in the reaction, and I'm assuming that B got completely consumed in the reaction. Okay, and that reactant which gets completely consumed in the reaction, that's what we call as limiting reagent. If B is the limiting reagent, A is what I call as excess reagent. That means, first of all, when B will get completely consumed in the reaction, still at that time there will be some amount of A left in the container. There'll be some moles of A left in the container, right? But there'll be no B in the reaction. But there'll be no B in the container, right? If there will be no B, there'll be few moles of A. Can I say a reaction will stop at that time? Right? Because there are no moles of B left in the container which can react with the left amount moles of A, correct? Right? So at that time, the reaction is going to get stopped. When one of the reactant gets completely consumed, the reaction stops at that time, okay? Right? So B is my limiting reagent over here, which I'm assuming it got completely consumed, right? Now remember one important point. Whatever product has got formed, it is entirely governed by the limiting reagent, okay? The number of moles of products formed in the reaction at the end of the reaction is entirely decided by the limiting reagent. Remember this thing as well. You will get the clear-cut idea after a few minutes when I'll be solving the questions, okay? So first of all, remember that reactant which gets completely consumed in the reaction, that's what we call as limiting reagent, number one. Number two, that reactant which does not get completely consumed in the reaction, that's what we call as excess reagent. Your entire product is governed by the limiting reagent, okay? The number of moles of C formed, the number of moles of D formed, that will be entirely decided by the limiting reagent. How come and when? Understand properly what I'm going to say. Understand properly what I'm going to say. Properly understand. See guys. For example, I've got a reaction as N2 gas plus H2 gas. Now understand. H2 gas, it gives NH3 gas. Yeah? This is the reaction which is given to me. And for example, at time t is equal to 0, I'm starting with 10 moles of N2 and 10 moles of H2 as well. Okay? At time t is equal to 0, will the reaction have got is the reaction started at time t is equal to 0? No. If the reaction has not started at time t is equal to 0, I'll say number of moles of NH3 formed at time t is equal to 0 will be 0, right? Now people understand. Now people understand. Remember when to use the limiting reagent concept. Whenever you'll be given with the amounts of all the reactants, these amounts can be in terms of moles, these can be in terms of mass, these can be in terms of volume. Whenever you'll be given with the amounts of all the reactants, at that time you'll be using the limiting reagent concept. Now remember, the first step of the limiting reagent is always to balance the reaction. The reaction is not balanced, so let me balance the reaction first. The first step to use the limiting reagent concept is to balance the reaction. The reaction is balanced now. Okay? Now after balancing the reaction, how it's time to identify the limiting reagent, right? I'm sorry. After balancing the reaction, what do we do after that? We try to identify which one is the limiting reagent, which reactant gets completely consumed in the reaction. And how do we identify that? Understand. We have got two reactants. One is N2, one is H2, right? What is the stoichiometry coefficient of N2? That's 1. What is the stoichiometry coefficient of H2? That is 3. How many moles of N2 we took in the starting? We took 10 moles of N2. And how many moles of H2 we took in the starting? We took 10 moles of H2 as well, right? Now, how do I identify which one is the limiting reagent? Simply divide the given moles of reactants by their respective stoichiometry coefficients. Divide the given moles of reactants by their respective stoichiometry coefficients, right? Okay, now people see. Over here I get the value 10, over here I get the value 3.33. Which one is the lesser value? This 3.33 is the lesser value. The one whose value comes out to be lesser, that's always my limiting reagent. So I got to know H2 is my limiting reagent, okay? So first of all, you got to know H2 is your limiting reagent, right? What does that mean? That means when the reaction would have started, after some time, H2 would have got completely consumed in the reaction, right? So I started with 10 moles of H2. After some time, you will find out that there will be 0 moles of H2 left in the container. Yeah? There'll be 0 moles of H2 left in the container, correct? Now, when H2 would have got completely consumed, can I say at that time, the reaction would have stopped? Right? The reaction would have stopped. Correct? Now, since you identified which one is the limiting reagent, as I told you, your entire product is decided by the limiting reagent. Now, when the reaction has stopped, at that time, if I need to check that how many moles of NH3 have got formed, how do I do that? That is going to tell me what? Limiting reagent is going to give me the idea of how many moles of NH3 would have got formed at the end of the reaction. And how can we do that? How do we do that? Understand. See, first of all, remember, limiting reagent is going to give me the idea of how many moles of product have got formed. And how come? Understand. I'm going to use the stoichiometry now. See what I'll be doing. I'll say 3 moles of limiting reagent. As per the stoichiometry is concerned, 3 moles of the limiting reagent, which is my H2. 3 moles of H2 gives 2 moles of NH3, right? Gives 2 moles of NH3, correct? Now, as per the stoichiometry, I got to know 3 moles of H2 gives 2 moles of NH3. Why am I starting from H2? Because H2 is my limiting reagent and your entire product is decided by the limiting reagent, yeah? Now we will understand. 3 moles of H2 gives 2 moles of NH3. Can I say 1 mole of H2 should give me 2 divided by 3 moles of NH3? Yeah? 3 moles of H2 gives 2 moles of NH3. So 1 mole of H2 should give me 2 by 3 moles of NH3. So 10 moles of H2 should give me 2 divided by 3 multiplied by 10. Value will come out to be 6.66 moles of NH3. Yeah? So what you find out, you found out something that 6.66 moles of NH3 have got formed at the end of the reaction. Yeah? Right? You got to know 6.66 moles of NH3 have got formed at the end of the reaction. Correct? Point number 1. How did I get to know that 6.66 moles of NH3 have got formed at the end of the reaction? Limiting reagent gave me the idea about that. Okay? Now people, if I ask you about this N2, is N2 my limiting reagent or excess reagent? This is the excess reagent. So there will be few moles of N2 still left in the container. Yeah? Now I need to check how many moles of N2 are still left in the container. Again, limiting reagent is going to give me the idea of how many moles of excess reagent will be still in the container left as such. Again, limiting reagent is going to give me that idea. How come? Understand. Now people, see what I'll be doing. Now I'm going to relate the stoichiometry of the limiting reagent with the stoichiometry of this excess reagent. Yeah? Can I say 3 moles of limiting reagent reacts with 1 mole of excess reagent as per the stoichiometry? Yeah? I can say 3 moles of limiting reagent, which is H2. It reacts with 1 mole of N2. It reacts with 1 mole of N2. Yeah? 3 moles of H2 reacts with, I'm writing a term reacts with, okay? 3 moles of H2 reacts with 1 mole of N2. Can I say 1 mole of H2 reacts with 1 by 3 moles of N2? Okay, I got to know 1 mole of H2 reacts with 1 by 3 moles of N2. So can I say 10 moles of H2 10 moles of H2 reacts with 1 by 3 multiplied by 10, value comes out to be 3.33 moles of N2. So I got to know 3.33 moles of N2 have reacted with 10 moles of H2, right? So I got to know, okay, 3.33 moles of N2 have reacted with 10 moles of H2. But how many moles of N2 I took in the beginning? I took 10 moles of N2. Out of 10 moles of N2, how many moles of N2 have reacted? 3.33 moles have reacted. So can I say I'll be still left with 10 minus 3.33? I'll be still left with 6.66 moles of N2 in the container. Yeah. So can I say something like this? 6.66 moles of N2 will be still left in the container when the reaction would have stopped, right? So all this data, how many moles of NH3 got formed at the end? 6.66. How many moles of H2 will be left in the container? 0. How many moles of N2 will be still left in the container? 6.66. All this data you can only calculate if you know the concept of limiting reagent. Yeah. Let me know in the chat box so that I can solve some good questions on this concept so that you get the clear-cut idea of this limiting reagent. Okay. This might look a bit confusing, but when we'll solve the questions, you'll get the clear-cut idea of that. I mean, you will get the clear-cut idea of how to solve the questions in lesser time. Samarpita, if both the reactants gets consumed at the same time, no issues. You can take any one of them as the reference and you can get the product formed. Let's solve some questions, yeah? Let's solve some questions directly without wasting a lot of your time. Okay? So this is the first question which is on your screen. The first question which is on your screen. Understand. The reaction which is given to me, one benefit, I'm given with a balanced reaction from itself only. Okay, they have given me the balanced reaction. Correct? Is that? They have given me the balanced reaction. So my time is saved. Okay, I'm not supposed to balance the reaction yet. Right? I'm given with the balanced reaction itself. It's 6 times LH plus 8 times BF3. Okay, it gives 6 times LiBF4 plus B2H6. Okay, this is the reaction which is given to me, right? Now people understand properly what I'll be doing. At time t is equal to 0, on starting with 2 moles each of reactants. So at time t is equal to 0, I've got 2 moles of LH, I've got 2 moles of BF3. So at time t is equal to 0, since the reaction has not started, so there will be 0 moles of LiBF4 and 0 moles of B2H6 formed right now. Okay? Right? Golden Bio Gaming, bro, this is the English channel, that's why I'm talking in English, yeah? Right? Okay. So at time t is equal to 0, I'm given with 2 moles of each of reactants. I told you whenever you'll be given with the amounts of all the reactants, at that time we use the concept of limiting reagent, yeah? Now first of all, the first step for the limiting reagent is we are supposed to balance the reaction, yeah? But the reaction is automatically balanced. It's given balanced, right? Now we need to identify which one is the limiting reagent. How do I do that? I have told you, divide the given number of moles by the respective stoichiometry coefficients. 2 divided by 6 and 2 divided by 8. Which value is lesser? 2 divided by 8 value is lesser than 2 by 6. If this value is lesser, that means BF3 is simply going to be my limiting reagent. So I identified BF3 is my limiting reagent. So out of 2 moles of BF3, I'll say I'll be having 0 moles of BF3 left in the container. Okay? That means BF3 is getting completely consumed in the reaction. If BF3 is getting completely consumed in the reaction, so I'll say the reaction will stop at that time. Because one of the reaction has got completely consumed in the reaction. Now your entire product is decided by the limiting reagent. I told you already. Okay. Now the point is how many moles of these reactants have got formed, right? So no, this is limiting reagent concept. Okay. So now it is the time to calculate how many moles of products got formed. And how do I do that? I won't be only calculating the moles of B2H6 formed. No doubt in the question they were asked to calculate the moles of B2H6 formed. First, I'll show you how to calculate the moles of B2H6 formed, then moles of LiBF4 formed, then the moles of LiH which will be left in the reaction, which will be left in the container. Yeah? Golden Bio Gaming, this is my name, bro. You can say it from here also. Now people, first of all, let's get to know how many moles of LiBF4 have got formed as per the reaction. Your entire product is decided by the limiting reagent. I told you that, right? Over here stoichiometric coefficient is 8. Over here stoichiometric coefficient is 6. I'll be using the stoichiometry. I'll say 8 moles of limiting reagent, and the limiting reagent is my BF3. I'll say 8 moles of BF3. It gives 6 moles of LiBF4, yeah? 8 moles of BF3 gives 6 moles of LiBF4 as per the stoichiometry of the reaction. Why am I starting from BF3? Because BF3 is my limiting reagent, yeah? So if 8 moles of BF3 gives 6 moles of LiBF4, can I say 1 mole of BF3 should give me 6 divided by 8 moles of LiBF4, yeah? Can I say 2 moles of BF3? 2 moles of BF3 should give me 6 divided by 8 multiplied by 2. It will come out to be 12 divided by 8, which is going to be 1.5. So 1.5 moles of LiBF4 would have got formed at the end of the reaction, right? So I got to know at the end of the reaction 1.5 moles of LiBF4 have got formed, yeah? Number 1. Number 2, let's get to know how many moles of B2H6 have formed. Let's get to know how many moles of B2H6 have formed at the end of the reaction. And how do I do that? Again, I'll be starting from the limiting reagent, because limiting reagent is going to tell me how many moles of products have got formed. Limiting reagent decides your entire product, as I told you, correct? Now, I'll be relating the stoichiometry of BF3 with this B2H6, yeah? Can I say 8 moles of BF3 gives 1 mole of B2H6? Gives 1 mole of B2H6 as per the stoichiometry, right? 8 moles of BF3 gives 1 mole of B2H6. Can I say 1 mole of BF3 should give me 1 divided by 8 moles of B2H6? Can I say 2 moles of BF3 should give me 1 divided by 8 multiplied by 2? The value comes out to be 0.25 moles of B2H6. So I got to know 0.25 moles of B2H6 have got formed at the end of the reaction, right? Okay, right? Now people, it's time to identify how many moles of this excess reagent are still left in the container. Again, that's going to give me, limiting reagent is going to give me the idea of how many moles of excess reagent will be still left in the container. Let's get to know that as well. Let's get to know that as well. Understand? Let's get to know that as well. Okay? Now I'm going to relate the stoichiometry of the limiting reagent with this excess reagent. Can I say 8 moles of limiting reagent, can I say 8 moles of BF3 reacts with, can I say 8 moles of BF3 reacts with 6 moles of LiH, 6 moles of LiH as per the stoichiometry, right? 8 moles of BF3 reacts with 6 moles of LiH, yeah? Okay, if 8 moles of BF3 reacts with 6 moles of LiH, can I say 1 mole of BF3 reacts with 6 divided by 8 moles of LiH? Okay, right? If 1 mole of BF3 reacts with 6 by 8 moles of LiH, can I say 2 moles of BF3 reacts with 6 divided by 8 multiplied by 2, which is 1.5 moles of LiH? So you got to know 1.5 moles of LiH are reacting with 2 moles of BF3, right? Okay, or you can say something like this: 2 moles of your limiting reagent, 2 moles of BF3 actually reacts with only 1.5 moles of LiH, but I have taken 2 moles of LiH. So how many moles of LiH will be still left in the container? Initially, I took 2 moles. Out of 2 moles of LiH, only 1.5 moles have reacted. So 2 minus 1.5 comes out to be 0.5. So 0.5 moles of LiH will be still left in the container as such, okay, when the reaction was stopped. Yes, Pragati, yes, absolutely. Okay, right? Let me know in the chat box if the concept is clear so that I can move on to one more question. Let me know in the chat box. Let me know in the chat box if it is clear. And people, you were only supposed to calculate the moles of B2H6 formed. So the answer of this question was 0.25. No, Samuel, I'm not feeling sleepy. I'm used to, take class in the nights. I love to take class in the nights. Yeah? Right? So let me know in the chat box if you want me to move on to the next question. Thank you, Kashyap. Thank you. Yes, Bhumi, exactly. So should we move on? Should we move on? Let's move on. Let's move on. That's great, Anish. If you study till 3 a.m., that's wonderful. That's great. Keep on doing the same. Keep on doing the same. I'm sure you'll kill it. Perfect. I'll tell you my scenario when I entered into class 11th, I used to study for 10 to 12 hours a day. Okay? So do that. Do that. Then only you can do something. Perfect. Let's move on now. Let's move on to one more question. This question was asked in your JEE Mains. Okay? This is a JEE Mains, simple JEE Mains question. Right? Simple JEE Mains question. But in the actual question, the reaction was not given balanced. You were supposed to balance the reaction. Okay? The reaction was not balanced. You were supposed to balance the reaction. Okay? The reaction is, let me write it again over here. BaCl2 is reacting with Na3PO4. And what is the product which you are getting? You are getting the product as Ba3PO4 whole twice plus NaCl. Yeah? This is the reaction which is given to me. Now, as per the equation, understand. As per the equation, understand. At time t is equal to 0, I have got 0.1 moles of BaCl2 and I have got 0.3 moles of Na3PO4. So at time t is equal to 0, I'm starting with 0.1 mole of BaCl2 and 0.3 moles of Na3PO4. Can I say I'll be having 0 moles of this one and 0 moles of this one at time t is equal to 0 because the reaction has not started yet, right? Now people understand. Am I given with the amounts of all the reactants in terms of moles? Yes, I'm given with the amounts of all the reactants in terms of moles. And which concept do we use at that time? We use the concept of limiting reagent. What is the first step of limiting reagent concept? We are supposed to balance the reaction. Is the reaction balanced? No. Let's try to balance the reaction. This is 3, this is 2, this is 1, and this is 6. The reaction is balanced. Okay. What am I supposed to calculate? I'm supposed to calculate. You can just change the question like this. Don't write amount, write the moles. Calculate the maximum moles of Ba3PO4 whole twice formed. Okay. I'm supposed to calculate the moles of Ba3PO4 whole twice formed at the end of the reaction. Okay. Since I got to know that, I have to use the limiting reagent concept. I have balanced the reaction too. Now, it is the time to identify which one is the limiting reagent among the two. And how do we identify? Just divide the given moles by the respective stoichiometry coefficients. Divide the given moles by the respective stoichiometry coefficients. So over here you get the value as 0.033. Over here you get the value as 0.15. Which is the lesser value? This one is the lesser value. So automatically it becomes my limiting reagent. So I got to know your BaCl2 is my limiting reagent. Yeah. If BaCl2 is my limiting reagent, I'll say there will be 0 moles of BaCl2 left in the container at the end of the reaction. Okay. Right. So people, we identified BaCl2 as the limiting reagent. And I told you your entire product is decided by the limiting reagent. Let's try to get all these 3 dashes. Let's try to get all these 3 dashes. First, let's get to know the exact question which is asked. Calculate the moles of Ba3PO4 whole twice formed. As I told you, your entire product is decided by the limiting reagent. Yeah. So I'll be relating the stoichiometry of limiting reagent with this Ba3PO4 whole twice. Can I say something like this? 3 moles of, can I say 3 moles of BaCl2? 3 moles of BaCl2, it gives 1 mole of Ba3PO4 whole twice. Yeah. I can say something like this. 3 moles of BaCl2 gives 1 mole of Ba3PO4 whole twice. Why I started with BaCl2? Because it's my limiting reagent. And limiting reagent decides your entire product. Okay. 3 moles of BaCl2 gives 1 mole of Ba3PO4 whole twice. Can I say 1 mole of BaCl2 should give me 1 by 3 moles of Ba3PO4 whole twice, right? So can I say 0.1 moles of BaCl2 should give me 1 by 3 multiplied by 0.1. The value comes out to be 0.033 moles of Ba3PO4 whole twice. So I got to know these many moles. 0.033 moles of Ba3PO4 whole twice have got formed at the end of the reaction. Yeah. Okay. Suryansh, I'm right now live from Srinagar, Jammu and Kashmir. Okay. Right. I'm from Srinagar actually. Yes, Kashyap, you were right. Okay. If I ask you how many moles of NaCl have got formed at the end of the reaction, you can tell me that too. You can tell me that too. Again, let me erase this part. Okay, let me erase this part. Now let's try to find out how many moles of NaCl have got formed at the end of the reaction. Now I'll be saying 3 moles of BaCl2 gives 6 moles of NaCl. Yeah, gives 6 moles of NaCl. If 3 moles of BaCl2 gives 6 moles of NaCl, can I say 1 mole of BaCl2 gives 6 divided by 3, which is 2 moles of NaCl? So I got to know 1 mole of BaCl2 gives 2 moles of NaCl. So 0.1 moles of BaCl2, 0.1 moles of BaCl2 should give me 2 multiplied by 0.2. Value comes out to be 0.4 moles of NaCl. So I got to know at the end of the reaction, you'll be having 0.4 moles of NaCl at the end formed over here. Yeah, right? Right? So you got to know 0.4 moles of NaCl have got formed at the end of the reaction. Okay? Correct? Oh, is it 0.1? All right. So my bad. This is 0.1. So the value comes out to be 0.2, not 0.4. So it is 0.2. Okay. So 0.2 moles of NaCl have got formed at the end of the reaction. Correct? Now, people, I'm giving you one question as the homework. Okay. That's something which you'll do. Or let's not keep, should I be giving you this as the homework, or you want me to do it right now? Should I be giving you this as the homework, or you want me to solve it right now? Do let me know the answer of this question in the comment box, okay? Not now. Okay, do let me know the answer of this question in the comment box. So people, with this, we end the today's discussion, right? Exactly. I want all of you to give it a try. I want all of you means all of you, okay? And let me know the answer in the comment box. So people, let me tell you, on Monday, I'll see you all again at 10:30 sharp. Okay, and on Monday we are going to do one more important topic, that's percentage purity and percentage yield. Okay, and at the same time, one more important thing, I'll be taking your classes 3 days per week. Okay, 3 days per week I'll be taking your classes, right? And I'll be keeping the class for 1 hour 30 minutes. Okay, right? Perfect. Yes, Arushi, I gave you the question, right? That was the question. Alright, so people who are new to the channel, who have no idea about the Vedantu JEE Pro subscription, well people, the batch is starting on 10th of May, okay? Do get enrolled in it, okay? Do get enrolled. We have got 3 plans right here in the Pro subscription. If you want to see the exact Vedantu classroom, if you want to see how we take classes in for the internal students, right? Okay, in the on the actual Vedantu platform, on the Wave platform, which we call it as, right? Then you have to take one of these Pro subscriptions over here. Well, people, it's not necessary. If you might get confused like this. See, this plan, it's valid for 2 years. For 2 years you have to pay this much of amount. Okay, and people, it's not necessary to pay this much of amount in one go. You can pay this in installments as well. Vedantu has kept an option of EMI. Okay, by doing that procedure, you can pay the monthly amount as well, and this is the course fees for 2 years. That means we are going to train you personally in your class 11th as well as class 12th till your JEE 2023. Point number 1. Point number 2, what all things do we get in this? First thing, your whole course of class 11th, class 12th will be done on the actual Vedantu platform. Okay, and at the same time, there will be live interactive online classes through this program, light program, right? Test series and analysis will be there. Notes and study material, trust me, it is one of the best study material. If you are getting the Vedantu study material, no need to consult any book, I'm telling you, okay? There will be doubt solving during the class itself, right? Well, if you are new to Vedantu, you have no idea of how Vedantu looks like from inside. You can try it out for a month as well. You can try it out for a month as well. Give it a try for a month. If you are actually liking it, then only you can take the course of 2 years, okay? I'm telling you, if you are new to Vedantu, just you can try this for a month as well, okay? Just give it a try. If you are actually liking it, if you are actually getting benefited from it, then you can go for the 2-year classroom program, in which you have to pay this much of amount. This is not per year you have to take this much amount. No, this amount is for complete 2 years, right? And you can pay this much in installments as well. And at the same time, there is one more program which we have, that's Classic. What all features do we have Classic? Let me tell you, whatever features were there in Light, apart from those features, we have got doubt solving on mobile app, right? Whenever you feel any sort of doubt, you can write the doubt in the app, and at that time itself you'll be getting the answers of those doubts. Okay, right? And this is the course fee for 2 years, and you can pay this fees in installments in EMI as well. And people, if you want to give it a try, you can give it a try for a month. Okay, you can give it a try for a month as well. If you are actually liking it, then you can go for the 2-year program, right? And at the end, why the cost of this much is a little higher? Because in this plus subscription, what do we get? You get the personal mentor in all the 3 subjects. Apart from all the features which were there in Classic, apart from those features, you get the personalized mentor in your physics, chemistry, as well as mathematics. So if you want to give it a try for a month, okay, then only you want to decide whether you want to take it or not. Give it a try. Okay, this is the fees for 1 month. You can just give it a try. If you're actually liking it, then go for 2-year program as well. Okay, so this fees over here, these are for 2-year programs, and at the same time, no need to pay this fees in one go. You can pay this fees in installments as well. Vedantu has kept that option for you guys, right? And if you want me to train you personally in your chemistry, do not forget to use this coupon code WSPRO, Wassim Sir Pro subscription. This is my code if you want me to train you personally for these 2 years, for your class 11th as well as class 12th till your JEE 2023. Okay, and after using this coupon code, you are going to get the discount as well, additional discount of 10 to 20% you'll be getting, right? Perfect, right? That's great. Samarpita, did you use this code? Wonderful. Great. So people, how to get enrolled in this? There is a link in the description box of the video. Click on that link and select any one of these plans. Okay, and you do not forget to use the coupon code as WSPRO. Okay, I'm sure I'll see you all in my long-term batch, okay, which is starting on 10th. At the same time, there is one more link in the description box of the video, which is for the Telegram. Do click on the link, get added to the Telegram group, and stay updated about the classes. And at the end, for the ones who have not liked the video yet, please and please do like the video, share, and subscribe the channel as well, so that you get the notification of every single session which I'll be taking here over here, yeah, in this channel. Samuel, my birthday is on 6th April. Sagar, well, this is the English channel, that's why I'm talking in English. Well, you can join in the pro subscription, wherein I'm given the particular Hindi batch, where I'll be teaching in Hindi as well, right? So people, do not forget to get the pro subscription, do not forget to get enrolled in my long-term batch, and do not forget to use the coupon code as WSPRO. So I'll see you guys on Monday at the same time, but do not forget to do the assignment question which I gave you, right? Do let me know its answer in the comment box. So I'll see you guys day after tomorrow at the same 10:30. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.